So here we have to remove the healing abutment from the site, from the tissue. We're going to save this because we will put it back in a few minutes. A direct impression is planned. The impression system is a two-piece system with an octagon base which engages the internal design of the Cybron implant and the screw which threads it into position. A hex tool is used to place the impression coping. The two-piece impression coping is inserted into the implant. A radiograph is taken to ensure a complete seat of the impression coping. This is a mandatory protocol procedure to ensure that the impression coping engages the implant completely. You can't have any separation or black lines between the impression coping and the implant. Polysiloxane impression is made with light and heavy body materials. Note the clean contours of the impression. The impression coping must be retained properly in the impression to ensure a proper abutment and crown fabrication. There's no voids in this area. The impression coping is removed and placed into a laboratory analog which simulates the implant design. And here we have an analog, and the impression coping is simply hand tightened into position. The impression coping and analog is carefully placed into the implant impression. Now you could allow the laboratory to do this under magnification if you prefer. The healing abutment is replaced in the mouth while the dental laboratory is fabricating a master cast using the implant analog to fabricate the proper abutment and crown. Again, the healing abutment, you can see the tissue around the healing abutment, and we will remove this prior to placement of the prepared abutment that the laboratory created for us. So we're using our hex tool to remove the healing abutment. Here, the prepared abutment is torqued into position at 25 Newton centimeters, and a radiograph is taken to ensure complete seating of the abutment into the body of the implant. A piece of cotton or silicone is placed into the screw hole after torquing to place, and a little cavity is used to cover the screw hole prior to crown cementation. I always want to be able to get back to my implant itself if there's any problems. If there's problems with the crown, with porcelain chipping, contacts, or if there is any infection or problems around the implant, it's nice for me to be able to remove the crown, remove the abutment, and get back to the body of the implant if I need to. Different designs and types of crowns can be fabricated by the dental laboratory, including aesthetic and durable zirconia crowns, conventional porcelain fused to metal crowns, or crowns intended to be used for bruxers, like the bruxer solid zirconia materials. In this situation, it was determined that the zirconia crown was the most aesthetic and would be the most durable. The translucency appears to be the best of the three choices that I just gave you. That's zirconia. Here's a PFM. You can see just a traditional PFM crown and the bruxer solid zirconia crown, which is rather opaque. The zirconia crown creates a warm essence. The PFM was much more opaque. And the bruxer crown was opaque but very durable. So we decided on the zirconia, and we cemented the zirconia crown into position. So the final radiograph of the implant retained maxillary first molar cemented into position. Here we're showing a digital radiograph of the contralateral maxillary left first molar, the edentulous space, and ideal position of the implant. The healing abutment, as we demonstrated earlier, is placed immediately after a flapless surgical procedure. Here the healing abutment is in position and removed using a hex tool. A tissue cuff around the integrated Cybron implant here is illustrated. Here you can see the internal design of the 4.1 by 9 millimeter XRT Pro Cybron implant. Here a hex design impression coping is used. Again, it's a two-piece system that engages the internal design of the implant. The impression coping is in position and checked for complete seating using a radiograph. And here a little bit different than the other side. Here we have the platform switching design, whereas we use a more conventional technique that engaged the outside of the body of the implant previously. A polysiloxane impression is made using light and heavy body materials. A nice clean impression of the impression coping is made. Now, if you look at this impression, you can see on the very top of the impression where the implant would be, you see a flat area. And the impression coping does have a flat side to it, so it allows you to replace it quite readily. The impression coping is placed into the implant analog used by the dental laboratory to simulate the actual implant position in the mouth. The impression coping and analog are placed into the final impression. The healing abutment is replaced and torqued into position while the dental lab fabricates the prepared abutment and crown. And again, the healing abutment is in position. The dental laboratory will then prepare the titanium abutments and the final crowns that we will place in the mouth. The healing abutment is again removed from the mouth prior to prepared abutment seating. You can see a little bit of plaque around the healing abutment. Here's the body of the implant. Here, the abutment is taken to the mouth. A hex driver is used to engage the internal design of the implant, and the abutment is torqued to 25 Newton centimeters. The abutment screw opening is again covered with either silicone or cotton encavit prior to crown cementation. A radiograph of the abutment in the proper position. Again, choices can be made on the type of crown that you want to use, whether it be a zirconia, a PFM, porcelain fused to metal, or a material used for bruxers like the Bruxer solid zirconia material. Here, a zirconia crown was chosen for its aesthetics. This slide illustrates a porcelain fused to metal crown try-in, and you can see it's not quite as aesthetic as a zirconia crown. And here the Bruxer material is very opaque and not very aesthetic, but very durable. And our last slide shows the final radiograph of the zirconia crown in place in the maxillary left first molar.